In this theorem, it said, what if one chord, this AP is a chord, and one tangent, this PT, point of contact is T. What if they intersect? Okay, this diagram is very similar to this diagram, except that this line that you see here, this becomes the tangent, right? In this case, then what happens? Then, according to this theorem, you can write the square of the length of the tangent, PT square, must be equal to product of the length of the segment of the chords, must be equal to PA into PB. Okay, this is what the theorem states. Okay, so remember, square of the length of the tangent must be equal to product of the length of the segments. Okay, so let us see one small example from this theorem. Look here, in the figure given below, PT is a tangent. Okay, so you see that this length here from P till T, this is the length of the tangent. Okay, find TP or PT if AT is equal to 16 centimeter. So this length is given to you as 16 centimeter and AB is 12 centimeter. So this is given to you as 12 centimeter. These are the measurements given, and you have to find out the length of the tangent PT or TP. Now, from the above theorem, you see that this chord here and this tangent here, they are intersecting at T. So therefore, from this theorem, you can write TP square, that is the square of the length of the tangent, must be equal to product of the length of the segments of the chords. That means PA into, this is TA into TB, right? PA into TB, right? Now we simply need to put the values here. What is the length of TA? TA is given to be 16. And what is the length of TB? TB, if you see, is nothing but 16 minus 12, right? TA minus AB, right? So you're getting 16 into 4, which is equal to 64. So TP square is 64. So therefore, how much is TP? Square root 64, which is equal to 8 centimeters. And that is the required length of the tangent. Okay. Good enough. Let's move to some problem from the exercises. Having discussed all the theorems with examples, now we are going to discuss all the theorems in totality. That is, which theorem to use where. Out in the last exercise, you knew which theorem to apply in which problem. This time you don't know which theorem to apply. You have to choose from among the theorem because all the problems are mixed. Okay. Let's see this. In the figure given below, quadrilateral ABCD is circumscribed and AD is perpendicular to DC. Quadrilateral ABCD is circumscribed means that around the circle you have a quadrilateral ABCD, which you can see, right? And AD is perpendicular to DC. So you can see this 90-degree angle here, right? So this is a 90-degree angle. AD is perpendicular to DC. This is already marked in the figure. Question is, find X if radius of the in circle is 10 centimeter. In circle means the circle that is inside the quadrilateral. Okay. If its radius is given, okay, you need to find out the value of X. And what is X? X is nothing but the length of this DC. Okay. So let's see how to find. First of all, from O, you drop a perpendicular on DC. Okay. So that this becomes a square. This becomes a square. Okay. Why does this become a square? Because one angle is 90 degree and also this length is the radius and this length is the radius. So this is also 10 centimeters because it is the radius. And what is a quadrilateral in which adjacent sides are equal and one angle is 90 degree called? It is called a square, right? So this is a square. Okay, so so this is 10. Now if this is a square, this is also 10 centimeters, right? So we have got this length 10 centimeters. Now if you see this length SD is the tangent to the circle from the point D, and similarly this length DR is also a tangent from the point D. So this length dr must also be equal to 10 centimeters. This length, right? Because tangents to a circle drawn from an external point are equal. Length of the tangents drawn from an external point to a circle are equal, right? So this must be SD must be 10 and dr must be 10 centimeters. Now look at the point B. From the point B, you're drawing two tangents, right? BP and BQ. These two are the tangents. What is the length of BP? 27. So therefore, the length of BQ, this length, must also be 27 centimeters because tangents, length of the tangents drawn from external point to a circle are equal, right? So this is 27 centimeters. Now if this is 27 centimeters, how much is this length? The entire length is 38. So this must be 38 minus 27, which is equal to 11 centimeters. Now if this length here is 11 centimeters, and now if you consider the point C to be an external point from which two tangents are drawn, CQ and CR. So this is your tangent CQ. What is the length of this tangent? 11 centimeters. So therefore, what should be the length here? This should also be 11 centimeters. So therefore, what is this length in totality? 10 plus 11, which is equal to 21 centimeters. Okay. So that finishes this problem. Let's see the next question. Right. In the figure given below, O is the center of the circle. So center of the circle is given to you. And AB is a tangent.
Morning, sir.
Morning. AB is a tangent. Okay. So the point of contact of the tangent here is this. AB is a tangent at B. If AB is equal to 15 centimeters, so this length is given to you as 15 centimeters. Right? And AC is 7.5 centimeters. This length is given to you as 7.5 centimeters. Right? Find the radius of the circle. Okay. Now this question, the way I have solved below, if you see, I have joined these two and I have taken this radius as X and this radius as X. So this angle becomes 90 degree. Why does it become 90 degree? Because radius is perpendicular to the tangent at the point of contact. So OB perpendicular to AB. And what have I done? This length, this entire length here, length of the hypotenuse becomes X plus 7.5, right? This length here is already given to be 15, perpendicular is given to 15, and base here is X. So what have I done? I have written OA square is equal to OB square plus AB square, right? And I have put the values. OA here is X plus 7.5 square is equal to OB square X and AB square 15. And what have I done after this? I have solved this equation to get the value of X. But here out here, you can see the solution for this. Okay, so I'm not going to work out this way. I have a more easier way of working this out. Okay. Now what is the easier way? Let's see. See, you don't need to join this here in this case. If you remember the last theorem that I discussed, what was the last theorem that I discussed? That if a chord and a tangent intersect, right? If you see AB is a tangent and also this AD, not AD, in fact, CD. This CD, if you see, is a chord, right? It is a special chord, which is called a diameter, but it's still a chord, right? It is a special chord, but it's still a chord, isn't it? So therefore, CD is a chord. So in this case, if you see, the tangent and the chords are intersecting, right? So therefore, what can you write? Length of the tangent, AB, square of the length of the tangent, AB square, must be equal to the product of the segment of the chords, right? And what are the segments of the chords in this case? Segment is AC into AD, right? So now you put the values here. So AB is given to be 15, AC is given to be 7.5, and AD you need to calculate, right? So that means AD here is If you divide both sides by 7.5, you're going to get 15 square by 7.5. So this is 15 into 15 divided by 7.5, which is 15 into 15 into 10 divided by 75. So I've shifted one decimal in the denominator. That is why I multiplied the numerator by 10. Okay. So I can cancel this here with 5 and this here with 2. So you're getting this as 30. So this entire length you are getting as 30. Right? So what is the length of the diameter here? DC. Therefore, DC is, this length here was how much? 7.5, isn't it? So DC is 30 minus 7.5, right? Which is equal to 22.5. So if the length of the diameter is 7.5, what should be the radius? Radius OC, or you can say OD, is equal to half of the diameter, which is 11.25. Okay. This is another way of doing this problem. Yeah, you can go through the solution that I have given you. Otherwise, you can always follow this method also. No problem. I'll continue with the next question then. Look at this very interesting question here. In the figure given below, ABC is a triangle with AB is equal to 10 centimeters. So this length is given to you as 10. BC as 8 centimeters. So this length is given to you as 8 centimeters. And AC as 6 centimeters. Okay. 3 circles are drawn touching each other with vertices A, B, and C. So all the 3 circles, they touch each other. Okay. With centers A, B, and C. Vertices means center. With vertices A, B, and C, that is the points A, B, and C as the centers. Find the radii of 3 circles. You need to find the radii of all the 3 circles, right? Now, recall, when 2 circles touch each other, what can I say about the point of contact of the centers? That they will always lie on the same straight line. That means I can say BC is a straight line, right? And I can also say AB is a straight line. And I can also say AC is a straight line, right? Okay. So now once I say that, now if I take the radius of this circle as X, so these two both will be equal to X because both these are radii, right? If I take the radius of this circle as Y, this will also be Y because both are radii. And if I take the radius of this circle as Z, then this will also be Z because both are radii, right? Now if you see, what can I write? The lengths are given here. AB, what is the length of AB? It is X plus Y, isn't it? And what is the length of AB given here? Length of AB is given to be 10 centimeters, right? So this is our first equation. Also, if you see, the length of BC is Y plus Z. And what is the length of BC given here? 8 centimeters. So this is the second equation. Also, EC, the length is XZ plus X. And Z plus X, what is the length of EC given here? Is 6. So we are getting 3 equations in X, Y, and Z. Now you need to solve these 3 equations. Now the interesting way is how to solve these 3 equations. Okay. The best way of solving, you can have many ways of solving. This is actually an example of a simultaneous equation in 3 variables, X, Y, and Z. Okay, if you see X, Y, and Z are unknown, and you have 3 equations. In your class 9, what had you done? You had done 2 variables, X and Y, and 2 equations were given. But in this case, you have 3 variables, X, Y, and Z, and 3 equations are there. And that too, a very interesting form is there in this. Okay, whenever you get this kind of an equation where X plus Y, Y plus Z, and Z plus X, and you have to solve for X, Y, and Z, this is the way you are going to follow. First, you are going to add 3 equations. Adding 1, 2, and 3. You will get X plus Y plus Z plus z plus x is equal to 10 plus 8 plus 6. Okay. Now you are going to, you see that you have a 2x's, so you get 2x, you have 2y, so you get 2y, and you have 2z is equal to 24. So now from here you can take 2 common from the left hand side, you get twice x plus y plus z is equal to 24. That means you get x plus y plus z is equal to 24 by 2. That means x plus y plus z is 12. Right? Call this equation number 4. Right? Now we need to use this equation number 4 to solve for x, y, and z. And from where have we got 4? We have got 4 from 1, 2, and 3. Okay. So how do we solve? How do we use 4 to solve for x, y, and z? See, from 4, if I subtract, let's say, if I subtract 2 from 4, because I want to get the value of x, how will I get? X plus y plus z minus, and this is one is your 2, z, sorry, not this one. This one is your 2 here, right? Minus y plus z. What is the right hand side here? 12. And what is the right hand side here? 8. So now if you see, x plus y plus z minus y minus z is equal to 4. So how much are we getting the value of x? 4 centimeters. This is the way you will solve for y and z also. See that when I wanted to solve for x, I subtracted from 4, I subtracted 2, right? Now, if I want to get the value of y, from 4, which equation will I subtract? I'm going to subtract 3, right? So subtracting 3 from 4. What will I get? X plus y plus z minus z plus x is equal to right hand side of 4 is 12 and the right hand side of 3 is 6. So what am I getting? X plus y plus z minus z minus x is equal to 6. That means z and z cancel, x and x they also cancel. You get y is equal to 6 centimeters. So the radius of the circle with center B is 6 centimeters. The radius of the circle with center A is 4 centimeters. And what remains? Only z remains. So from 4, which one am I going to subtract? 1. Okay. So subtracting 1 from 4. We get x plus y plus z minus x plus y. And the right hand side of 4 is 12. And what is the right hand side of 1? It is 10. Right? So you're going to get x plus y plus z minus x minus y is equal to 2. That means you're simply going to get z is equal to 2 centimeters. And that should be your answer. So the radius of the circle with center C is 2 centimeters. So x is 4, y is 6, z is 2. And that is your ultimate solution of this problem. Okay. Unless you have questions, I can move on to the next question to discuss. This one. This should be an easy one. In the figure given below, PQ is equal to 24 centimeters. So this length is given to be 24 centimeters. QR is 7 centimeters. This length is given to be 7 centimeters. And angle PQR is 90 degrees. That means this angle is given to you as a right angle. So this is a right angle triangle, PQR. Okay. Question is, find the radius of the inscribed circle of triangle PQR. You need to find out the radius of the inscribed circle. That means this circle that you see inside the triangle. You need to find out the radius of this circle. Okay. How will you find? If you remember question number 1, very similar to that, what you do is you from here you drop a perpendicular on this, and let us call this n, so that you complete this square. Okay. Again, why do I say this is a square? This is a square because this is equal to this, because they are radii, and this is a quadrilateral. Therefore, this becomes a quadrilateral in which opposite sides are adjacent sides are equal, and one angle is a right angle. That means this must be a square, right? So we drop a perpendicular here so that this becomes a square. If this is x, this is also x centimeters. Okay, this is also x centimeters, and this is also x centimeters. Why is this x? Why is this x centimeter? Because it is a square. Opposite sides of the square are equal. Okay. So you have got this length as x. This much length you have got. Okay. Proceeding to the next one. Now see, if you have this as x, this length, right? Then what is the remaining length here? That is Pn. What is this length? 24 minus x, right? This length is 24 minus x. Now, if you consider P to be the external point from which I am drawing two tangents to the circle, then if I call this point as L, okay, then what is the length of PL? It is also 24 minus x, because length of the tangent drawn from an external point to a circle are equal. So if Pn is 24 minus x, PL will also be 24 minus x, right? Okay. So once I've got the length of PL, now if you see this length here, how much is this length? This entire length is 7 centimeters, and this length is x centimeter. And this length must be equal to 7 minus x, right? Now, if this length is 7 minus x, and if r is an external point from which I am drawing two tangents, then this length must also be 7 minus x, right? And what is the length of, therefore, what is the length of PR here? PR will be equal to 24 minus x plus 7 minus x, right? Which is equal to 31 minus 2x. This is the length of PR. Okay, once we have got the length of PR, what you must also observe is that PQR is a right angle triangle, right? So erase all this. What you also observe is that this is a right angle triangle in which this length is 24 and this length is 7, right? So therefore, PR square must be equal to 24 square, or let's say PQ square plus QR square. QR square. So you can find out the length of the hypotenuse from here, 24 square plus 7 square. Okay, and it should be equal to, I'm not calculating here, this should be equal to 25, 625. That means PR must be equal to 625. So PR is equal to 31 minus x, and PR is equal to square root 625, which is equal to 25. PR is equal to 25. So therefore, I can say 31 minus 2x must be equal to 25, and from which you can find out the value of x. So you have 31 minus 25 is equal to 2x. That means you get 2x is equal to 6. That means you get x is equal to 6 by 2. Get x is equal to 3 centimeters. Okay. So easy enough question. Let's move to the next problem. Very interesting problem, this one. Observe very carefully. Let's see what is given first. In the figure given below, AB is equal to 8 centimeters. So diameter of the semicircle is given to be 8 centimeters. M is the midpoint of AB. M is the midpoint. That means this length is 4 centimeters. And this length is 4 centimeters because M is the midpoint of AB, right? Okay. Semicircles are drawn on AB, AM, and MB as diameters. So semicircles are drawn with AM as a diameter. You can see this AM. This is one diameter. AB as one diameter. Obviously, this is a semicircle, the biggest semicircle, and MB also. So this length also a semicircle is drawn with MB as diameter. Okay. Next, a circle with center C touches all three semicircles as shown. Now this circle here with center C touches both the semicircles. Okay, with AM and MB as diameters, right? Okay. Question is, find its radius. Its radius means radius of this circle with center C. Find the radius of this circle with center C. Okay. So how do we proceed about this? Let's see. So I have diameter of the semicircle given to us as AB, which is 8 centimeters. So AM must be equal to 4 centimeters. MB must be equal to 4 centimeters, right? Now, see, if I take because we need to find out the radius of circle with center C, let's take the radius of this circle as X, right? If this circle is of radius X centimeters, okay, and what should be the radius of this circle here? Diameter is 4 centimeters. Diameter of this semicircle is 4 centimeters, right? So what should be the radius? Radius is only 2 centimeters. So this length here must be 2 centimeters. So that this entire length becomes how much? X plus 2, right? Similarly, this is also because the diameter is 4 centimeters. This is 2 centimeters. So that this length becomes how much? Again, X plus 2, right? So what does it suggest about the triangle? If you see this triangle here, if you see this triangle here, what do these lengths suggest about this triangle? That this length here is X plus 2, this length here is X plus 2, okay, and let's say if I call this as R, this point, and if I call this point as S, then what can you say about triangle CRS? We can say triangle CRS is isosceles. Why? Because CR and CS are both equal to X plus 2 centimeters. So we can say that this is an isosceles triangle, right? And from here, if you see, M is the midpoint of this length, right? That is RS. And from the vertex, this dotted line passes. That means because this triangle is isosceles and because M is the midpoint, this must be perpendicular. This must be 90-degree angle, right? Because in a triangle, in an isosceles triangle, from if these two sides are equal, and from this vertex, if I draw a straight line which joins the midpoint of the opposite side, then what can I say? This angle must be 90-degree, right? So therefore, we say that CM must be perpendicular to AB, right? So now, what is the length here? This length is equal to 2 plus 2, which is equal to 4 centimeters, right? This length here is 2 centimeters, right? Okay. Now, if you see, this becomes a right angle triangle in which hypotenuse CS. What is the length of the hypotenuse? X plus 2. What is the length of the perpendicular? We need to find out. CM. We need to find out. And what is the length of MS? MS is 2 centimeters, right? That means we can find out the length of CM in terms of X. So from Pythagoras theorem, what can we say? CS square is equal to CM square plus MS square, right? So that means put the values here. CS is X plus 2. CM we need to find out. And MS is 2. So we get CM square is equal to X plus 2 whole square minus 2 square, which is equal to X plus 2 whole square minus 4. Okay. This is the length of CM that we are getting. Now, if I am to join, I've already found out this length, right, in terms of X. Now, if I am to join this here, that is, let us call this point T. Okay. Then I've taken the radius of this as X centimeter. This must also be X. So therefore, what is the radius of this? The radius of the semicircle, of the largest semicircle. Radius of the largest semicircle is CM plus CT, isn't it? This is the radius of the largest semicircle. CM we have calculated as X plus 2 whole square. Sorry, this should be, let me just simplify this a little. CM is square root of X plus 2 whole square minus 4, right? Which is equal to, now if you expand by A plus B whole square formula inside the radical, how much will you get? X square plus 4x plus 4 minus 4. So you're getting this simply as root over of X square plus 4x, right? And what is the radius of this largest semicircle now? CM we have got. CM is this length, root over of X square plus 4x. And what is the length of CT? CT is X, right? So this is the radius of the largest semicircle. But what is the radius of the largest semicircle given to you? Diameter is given to you as 8 centimeter. So therefore, the radius of this will be 4 centimeter. That means this radius here, MT is the radius, which is equal to MT. This length is equal to MT. This is also a radius, right? MT. So therefore, MT is equal to 4 centimeters. And what is the length of MT we have found out above? Root over of X square plus 4x plus X equal to 4. Now this is an equation that we need to solve. And once you are able to solve this equation, you will be able to find out the value of X. The solution part I have done in the notes. You can go through the solution. Okay. So this was a very critical problem and also a very interesting problem. If you have a keen understanding of circles, this was a very interesting problem. Okay. So I'll stop here for today.